point. It's getting later. We just had the keynote, which was excellent, I would say. So now we're going to take a bit more of a deep dive into the coding side of Semantic Kernel. Matthijs already did a lot of stuff with Semantic Kernel. He was working on the C# side. I work on the Python side. My name is Eduard van Valkenburg. I'm one of the software engineers who works on Semantic Kernel. I am based here in the Netherlands, but the rest of my team is in mostly Dublin and Seattle. But I'm lucky enough to actually just work from home on Semantic Kernel and talk a bit about it every now and then. Today, all about agents, obviously. So also on the Semantic Kernel side, I'm going to talk about agents quite a bit. I'm going to show different agents. But I'm first going to take a bit of a step back into how we as Semantic Kernel, the way we've kind of approached things over the last 2 years since we started. Because obviously since when we started, there were LLMs, but there were no agents, or at least the concept of an agent as it is now wasn't really around. So we've kind of started from a different place, but we've quickly adopted to also bringing agents and then actually making sure that you can leverage the investments you already made, bring those into the agent space, and vice versa. So we're going to talk about that. So for those of you who haven't heard about Semantic Kernel, it's a lightweight, open source. It's fully on GitHub, everything production ready, and we call it an orchestration middleware because that's really what it is. It isn't the front end. Matthijs was saying nobody likes to build a front end. I fully agree. We don't build the front end. We just build whatever you need to put in between different models, different vector stores, different other sources that you want to expose through whatever application you already have. Whether that's a new application like a chatbot or an existing application where you want to take over some little feature with LLMs or with agents more broadly. We've built it in Python, .NET, and Java so far. So like I said, I work on the Python version, the .NET version, obviously .NET being a Microsoft founded language is quite prominent. And then we also have a Java version, which is a bit less developed, I would say. But depending on customer feedback, we will continue investing in that one. We also have issues open for other languages. So if you do want to see Semantic Kernel in some other languages, feel free to add your comments there so that we have some idea of which languages make sense and where do we want to invest. So let's talk a bit about how we built up Semantic Kernel. So kind of the whole idea is that it's very modular. So we have abstractions for everything, and then we have different implementations that do the same things. Different model providers. So it is Microsoft created Semantic Kernel, but it's not limited to Azure or OpenAI. We support Google, Amazon, Anthropic, and then also local models, so Olama and Hugging Face locally. It's supposed to be an orchestrator across everything, and the thing you actually run with Semantic Kernel, you can run that anywhere. It's just code, right? And then we have the different other components. So, kind of the main thing I would say that you actually build in Semantic Kernel are the actual functions and plugins that you create that give your agent something to do with. We kind of have these two different ways of defining a function. So you can create them from a method, so that's from code, or you can create them from what we call prompt templates. We have different template languages that we support for that, including Prompty and then Handlebars, Jinja 2 for Python, and then one that we built ourselves. And then the functions for methods, those can be anything from like 2 lines of code to entire applications that you're calling into. That can be your print server or whatever it needs to be. Then we also can bring in other types of functions as Semantic Kernel functions, either through Open API specs, so you can just plug in your Open API specification. We create functions out of all of the methods that are there and expose those to the LLMs. or now, obviously, MCP. And then we also have a declarative file format that you can use both for these kinds of functions, and now we're extending that to agents and processes as well. And the nice thing about these YAML file-based approaches is that those YAML files can be shared between Semantic Kernel in Python and in .NET and in Java. So you can actually have one team developing these prompt-based functions or these agents with YAML, and then you hand over the YAML to some other team who work in some other language without them having to redo all that work. Then, once you have those functions, we bring those together into plugins. So a plugin is really nothing more than a container of related functions. And we do have some things that we do with that. So you can, for instance, filter out certain plugins that you do or don't want to expose to an LLM. So it makes it a bit easier to separate out the different functions that you have. Then the prompt functions, they actually always use an AI service to do a completion, and that's how they operate. So you give a template, you put in some parameters somewhere, or you can even put in other functions in there, so you can do like RAG-based lookups and stuff like that. Inside of your prompt template, it gets rendered. It uses an AI service, if needed, to get a completion of that piece of input, and then you get a piece of text back, or an image, or audio, or whatever it is. One really key, kind of more down in the weeds thing that we have in Semantic Kernel is what we call filters. We have different types of filters, and really what they allow you to do is they wrap the actual function call, whether that's from the LLM or directly, that doesn't matter. And we wrap them in the sense that your function that you create, your filter function, it gets called. You have access to the arguments that are being sent to the function, which function is being called, some other metadata things, any AI services if necessary. Then you can do stuff with that. So you can do checks if there's malicious content in the input. You can do caching with that. You can do all sorts of things with that. Then you can decide if it's actually calling the function, or you can even shortcut it. So if you're doing caching, you can actually catch the inputs, see what's in there, and say, hey, we already know the answer to this, so I'm just going to plug in the answer and throw it back without actually calling the underlying function. Then you call the function, and then you get access to the results. So you can then do checks on the results before they get sent back to the calling application. And then the calling application can be an LLM in a function calling loop, or it can just be a direct invocation of a function. With prompt rendering, we can do the same thing, and there it's nice because sometimes your prompt rendering calls a bunch of functions, does a bunch of work, and you don't want to do that every time for the same thing. Then we have connectors. That's obviously one of the other really big topics. There's a lot of effort on our end to make sure that all of the vector database that we support, that they all support the same ways of working, so that you can, with one line code change from Azure AI Search to Quadrant to Weaviate to whatever type of vector store you want to use. AI models, exactly the same. So whether you're moving from OpenAI to Llama to Bedrock, one line code change and you're up and running. And then nowadays we have a bunch of agent services that we support. So Bedrock agents, OpenAI Responses API, Azure AI Foundry Agent Service agents. Yeah, great name. And then we have our kind of our built-in agent, agent type, which is the chat completion agent. So there you can take one of those AI models, stick it in, add in whatever plugins, functions it needs, and then you have your agent. So the kernel is where we bring all of those pieces together. So you register your services, you add in your plugins, you add in your filters, and then you can start doing some stuff. And we have a whole bunch of other stuff that we have in there. So too much to cover now, but some of the key things are the content abstractions. So we abstract away the fact that the format that you get back from OpenAI is slightly different than the one you get back from Anthropic, and it's slightly different than what Olama gives you. We have single abstractions for all of those, so you always get the same result type back, and so your application can still, can do exactly the same things without having to do any work when you change models. And another really important one, and one that I worked on myself quite a bit, is the vector data and text search abstractions that we have. So basically what we've done there is made it so that you define your data model, you put in annotations next to the fields that you have in there, and then with that, we do all of the work of creating the specification of the index or the table or whatever the concept is for that particular vector store. We create that for you. We can do CRUD with that, so you can do, so you just create an instance of that class that you annotated. You can throw it into the update method, and it will just be uploaded into that store. The same with get, and then the same with search, and then different types of search. So text-based search, vector-based search, hybrid search, all of those things that you would expect. And then we can also really easily create functions out of those vector store connections, so that you can really easily expose exactly the interface towards the vector store that you want to expose to the LLM. So you can say, oh, I want a search function that has this name, it exposes these parameters. So it exposes maybe the query, but maybe also a particular filter for like a city or a country or something like that, that relates to the type of data that is in that data store. So rather than saying, oh, here's just a search function, you can actually craft that search function to really give the LLM the context to understand why it should call this search function rather than this other search function or some generic like Google search function. So then the main topic for tonight, which is the agent framework. At Ignite in November, we brought all of just the last month or so, we brought all of the agent frameworks to GA status. So that means we're not going to do any more breaking changes on those APIs. So if you adopt that latest version, then you can just keep updating without having to deal with breaking changes. And basically, I'm not going to talk too much about what is an agent, because the session before this went very deep into that topic. We have a similar definition here. But really what it is for us is it's those same pieces. So different connectors, different plugins, different filters that you bring together in the agent. Some agents have their own specific tools as well. So for instance, if you want to use a Azure AI Foundry agent, you can bring in the code interpreter tool and the fabric tool and all of those built-in tools that it has, but then still augment it with your own tools as well. So you're not limited to one or the other. You can use them side by side without any difficulty. Then some agent examples. I'm just going to skip over this. This is the group chat, but you saw a demo of how that works and how they talk to each other, so I'm not going to spend time there. So let's go demo stuff. So I'm going to go through a couple different demos. Obviously, there's MCP in there, but also a little chainlit demo to give some interface to just these kinds of code blocks. Is it legible in the back, or should I zoom in? Yeah, good. See a question?
A question about theory before we go further with the demo.
Sure.
You said that it's available in different languages. Why is that? Because it's API, right?
So what you build with Semantic Kernel, that is what you build with your own code, and you choose which language you want to use for that. In the back, there's APIs that we use, so at some point you don't have to worry about that, but the front-end application that this will connect to, it might be native to one or more of those languages, so you then can make sure to integrate without having to put in another layer there. Yeah. All right, so this is kind of the most basic, simple agent that we have. So in this case, it's a chat completion agent. I'm passing it the Ollama chat completion service. So in my environment settings, it knows which Ollama model to call. So I don't have to specify that. It gives a set of instructions. It's a single line, and then in this sample, it's going to, if it starts, is it starting now? There we go. Hello? I see something happening now. It's going to go through these two questions, so why is sky blue and what is the capital of France? And just to show that it's actually doing work now, let's have a look. In a second, you will see Ollama start to take up all of the memory because, yeah, this is not the most powerful machine, but I can run locally with my agents here. Is it actually doing something? Yeah. Should be. Hello? Come on, this is local. This should just work without Wi-Fi issues. Let's go. Yeah. All right, come on. You can do it. All right, let's see if the next one does want to actually do stuff. So this next one is going to call an Azure AI agent. So we call the Azure AI Foundry agent service agents, we just call them Azure AI agents to make it a bit more manageable. For the connection to that, you have to do a bunch of stuff because we first need to get an Azure credential, and then we need to create a Azure AI Foundry client, and then with the client we can get a agent definition, and then with that we can create the actual agent. So there's a bit of work involved for these kinds of agents, but once you have this agent thing, then it works the same as any other Semantic Kernel agent. So if the demo wants to do anything, what is going on? It just stopped. That's not fun. Let's go. Come on. Let's. These work. All right. So this is not cool, but it happens. Yeah. So what is happening in this demo is that we are adding in the code interpreter tool. So we can just call that in, add that into the agent definition, and then it has access to those resources. What it would do if it ran is actually calculate some Fibonacci feature sequences with the code interpreter running in the cloud. Then let's see if the next one maybe wants to work. So this one, it uses the MCP plugin. So to create an MCP plugin, all I have to do is take the same set of commands that you expect from MCP, and in this case, I'm using the GitHub MCP server running locally, connecting to GitHub online. And then I pass the GitHub plugin into my agent as one of the plugins, and then I can start asking it some questions. See if it does want to run, but probably not. Having not worked at all. So this is the way we kind of think about things, because it doesn't matter where the plugin is coming from. You just throw it in there. It will figure out how to use it, how to deal with it. Yeah, this is even more complex, so I'm not even going to try. So what I'm doing here is I'm actually taking two MCP servers that I created with Semantic Kernel, so they're in a separate file. I have one menu server, MCP server based on this plugin that I created, so this restaurant plugin. I have two Semantic Kernel functions, or three. Then I create an agent with OpenAI as the model, with the chat completion agent, with this plugin. And then all I have to do is call as MCP server on the agent, and then I have my server, and then I need to do, depending on how I want to run it, I run it either as STDIO directly or with a web server. And then I have another one that does restaurant bookings. So here I had some fun with the odds of being able to make a reservation. And then in this code here, I'm taking both of those agents that are running as MCP servers, connecting them into my main personal assistant, and it has actually three plugins, so the two agents from MCP, as well as a time plugin to make sure that it knows what time it is now, and I can ask it questions about time-related things. And then I can just chat with it if they would run, but let's give it another try, because why not? And so what you see here is different types of plugins, different other agents that I'm actually pulling into my agent to make sure that each agent is quite simple. It has one job, it has tools dedicated to that job, but then I can have a kind of a lead agent or a manager agent or whatever you want to call that agent that can call out to those different agents to do work. That one also doesn't work. And then the final piece here is the actual group chat that Matthijs was also talking about. I am creating two agents here. One is an Azure AI agent and the other is a chat completion agent. They both have their own instructions and names. And what this one does is in a group chat, create a slogan for a new line of electric cars. And so the copywriter would create a slogan, then the reviewer would review it, say, hey, I want, this is not concise enough or whatever they want to critique. And then once, with the approval termination strategy, once the reviewer says approved, then it exits out. And as Matthijs also said, quite important to have a maximum iterations set up so that you don't get running forever. And this is how simple the termination strategy is. It's just a matter of if improved is in the last message being sent, then it's fine. So if the agent says not approved, it will also stop. But yeah, that's why this is a sample and not a production system. So next I'm going to switch over because these do seem to work. because obviously Semantic Kernel is a fully code-based interface or code-based framework, so we don't have any front end, so we can rely on other tools like Chainlit to actually do a lot of the work for us. So what I have here is a small Chainlit application, and it's a single file, so it's quite easy. I created a plugin called the weather plugin. It takes a city as a parameter, and then depending on the city, it checks the weather for that city. I have some starters, and what's nice is we've built an integration with Chainlit where we can just take the Semantic Kernel thing and then create we've built in a filter into Chainlit that any function call gets shown as a nice step in the Chainlit interface. So I don't need to worry about any other thing other than just putting the kernel that this agent is using into that kernel filter thing in Chainlit, and then it's up and running. And then here is the main method. So that is this one. So with just that single line of, or that single file, I have an agent that I can now start talking to. So this one does work, so that's good. Here you can see the plugin being called. So it calls city, Seattle, and then it returns the weather, and then the actual LLM or the actual agent actually creates this response. And now I can start playing around with it, so I can do some stuff like so I can make it root. So it's reloading. I'm asking it for the weather again, so it is using the same plugin. So the basics still work. So the weather Nieuwegein. But now the response is a quite bit different. It's 15 degrees and cloudy. How exciting, enjoy the glue. So that's how easy it is to kind of play around with the different personas in these agents without having to do anything other than just changing the instruction a little bit. But we can also make it a bit more complex. So I don't want to just have a weather agent. I'm going to create a second agent. I'm just going to call this one agent. Personal assistant. All sorts of things. It's still snarky and rude, but now rather than giving it the weather plugin, I'm giving it the weather agent as a tool to use. And with that, I'm done editing and this reloaded. So I can still ask this question, but now what it's going to do is my personal assistant agent is going to call the weather agent to get the weather. It's just giving it back verbatim, but you can easily see how easy it is to start making different agents that do different specific tasks. So to take that a step further, I have a second one here. So this one creates a GitHub plugin from an MCP server. It then creates a GitHub agent. So I have one agent that talks to GitHub for me. It has my personal access token for that I've scoped to the Semantic Kernel repo so that I can have it help me in my job. It then creates a Azure AI agent with code interpreter so that it can start doing some code work for me. I'm also adding the file plugin, so the file system MCP server, so that I can actually have it interact with my local files in the Semantic Kernel project, so that I can actually start, bug fixes and that kind of stuff. And then I'm bringing all of those together in a single agent. So here I have my GitHub agent, my code agent. I'm adding the time plugin again, so that it can do some things with time. And then the rest is pretty much the same, other than the sample responses are a bit different. And now I have an agent that I can use to actually see what are the latest GitHub issues for Semantic Kernel. for Python. And then I can start using, and I plan to extend this to do more and more and more. Here you can see the different tool calls being done. So it's first calling the GitHub agent to get the latest issues for Python and not triaged. Any new issue that is created in our repo gets the tag triage, and then if it's Python related, gets the tag Python, so I can easily check which ones are related to what I'm doing. And now it's also calling the Azure AI agent. I'm not sure why, but let's let it run. Here we see a good example of how they sometimes mess up. And then once this comes back, it will show me a list of all of the different untriaged Python issues in our repo, and then I can start asking it further questions, and then start, telling it, hey, look in this file because the bug must be somewhere in there. See if you can identify it. So I can really start doing more of my work with it. So here we have the issues coming up. So we only have 3 new untriaged issues. One is actually one that I created myself as I was preparing for this demo. One is about some kind of N12 SQL agent. And one is about, looks like hotel telemetry not being produced correctly, so I'll let other people deal with that. And so now I can also say, hey, so I can just tell it, deep dive into this particular issue, see what's going on, see if anybody responded. So this gives me a lot of help in my daily work, but again, it's all about taking agents that do a particular thing, making sure that you define that well, that you give them the right tools, and it's even showing images now. That's new. And so they all work together, but I'm in charge of what they're actually doing. So, bunch of different demos. 4 of the 5 didn't work, so that's always good. I hope you have some idea now of how you actually create your semantic kernel agents, what they, how kind of easy it is to swap out different models, different types of agents, how you can just, play around with that, try out different models, different setups. Then the last thing that I wanted to talk about is the process framework. The process framework, we have no plans to rename it. Let's start with that. At least as far as I know, and I'm not in charge of that, so I could be made into a liar in 2 weeks. But so far, nothing, no changes going to happen there. But what we've seen with agents, and especially when you start talking about multi-agents in group chats, is that things become even more unpredictable. So what the process framework is intended for is to kind of give structure, because even if you're giving someone a task, you're still defining, hey, do this first, then do this, then do this. And you're kind of talking them through, depending on their level of knowledge, about what is expected in the first step and what kind of outcome is expected there. And then you kind of talk them through a process. Can be a fully formalized process in an organization, but it can also just be a way of working that has developed over time. And that is what this process framework does. It's basically bringing baseline stuff like the LLMs, the doc stores, the vector searches, and all of that. First bringing those into agents, and then bring those agents into a structured process where we can actually have them do meaningful work in the right way for the right step. Because what we've done in our agent framework, now this is a bit of marketing. So this is the important one. Each step can be a single function that gets called. So that can be fully deterministic code being executed. Can be a LLM-based function being called. Can also be an agent, a single agent. Can be a group chat, and it can be a whole nother process. So you can do whatever combination of steps that you want to do. inside of each step, and then you organize steps into a larger process with things like feedback loops, with fan out, fan in, all sorts of those kinds of constructs, and that's the patterns thing on the right, where we're defining some commonly seen patterns and making sure that those are really easy to implement, so you don't have to reinvent that every time. But the whole idea is a step is defined, the output of that step is defined, and we can check whether or not that step actually executed. And then all of this is an abstraction above multiple types of runtimes. A local runtime, so you can just run it locally, test it, debug it, but also distributed runtimes like Dapper and Orleans and other of those kinds of systems, and probably we'll add more over time. But the whole idea is long-running stateful processes with LLMs in the mix doing certain jobs. That's what this whole process framework is all about. So, final thing, what we're currently working on. There's a lot of work now being done on kind of the whole multi-agent setup. So agents themselves are generally available, so we're not going to change them anymore. But how they talk to each other, how they interact, that is an area that we're now doing a lot of work on revisiting that. That includes working together with the AutoGen team on bringing in some of the stuff that they've been working on, some of the research things that they're really good at. The goal for the next couple of months is to also bring the whole process framework up another level of robustness and quality, and then move that into GA. We have a lot of vector store stuff that we're close to putting in GA. And then all of what we do is on GitHub, so you can actually review our entire roadmap of issues and our project and everything. So if you want to know if something is in the works, just do a search in our issues list, so then you have some idea. But also, if you think we should do something, also let us know there. Here are the links to the different things to do that with. So our repo, the documentation side, and then we have weekly office hours where a bunch of people from our team are in the call. And it's usually a really good open discussion with a lot of people who are using it in different ways. So it's really fun to hear what people are actually doing. And then, especially on GitHub, create issues, create discussions if you miss something, if something doesn't work, because we love to hear it so that we can fix it. And with that, I am done.